So now that we've learned what a function is and we've seen some examples of how to identify a function, let's understand a specific type of function. There are two types of functions you should know about. The first are one-to-one functions. So what is a one-to-one function? Well, f from a to b is one-to-one. This is sometimes the slang notation mathematicians use because, they get lazy. A function is one-to-one when for all elements a and b in our domain A, if a is not equal to b, then f of a is not equal to f of b. So what this means is if you have two different elements in A, they go to two different elements in B. Something a lot more useful in math is this is very difficult to prove for a function whether it's one-to-one. So we oftentimes instead end up using the contrapositive of this, which is going to be for all A and B in A, if f of A is equal to f of B, then A is equal to B. This green statement is the exact same as our black statement, but the green statement, the contrapositive, is going to be much, much easier to prove and check for a function when we want to see whether or not it is one-to-one. Okay, so what's a good way of thinking about this? Well, abstractly, when you think of your two domains, your codomain, well, we'll just write this as B and our domain A, one-to-one basically means that when you have f of A like this be the same as f of B, it must be that they came from the same origin. This means that, for example, this is not one-to-one because f of A and f of B here are the same, right? The arrows go to the same location, but they originate from two different elements. So one-to-one means when something in B is hit by something in A, it is only hit by one thing in A. If it was hit by two, or let's say you had three, well, now you have three things that are equal to, like their codomains are equal, but their origin is not the same, right? If this was 1 and 2, let's forget about this third arrow for just a moment. If this was 1 and 2, we're saying f of 1 is equal to f of 2, but then we're arguing 1 and 2 are equal, which is obviously not going to be true because they're distinct elements in our set A.